number 2, we're going to find the area of a parallelogram bounded by the y-axis, the line x equals 3, the line f of x is equal to 1 plus 2x, and the line parallel to f of x passing through 2, 7. Okay, there's a lot of stuff going on. First of all, it's like, what does a parallelogram have to do with anything? Do I have to remember geometry? The answer is kind of, sort of, yeah. But anyway, so what we have to do, well, we know what the y-axis is. That's just the vertical axis where x equals 0, right? The line x equals 3, that's also a vertical line. The line given by this guy, we can graph that because we know how. What we have to do first is figure out what's the equation for the line parallel to f of x passing through 2, 7. So this is the important thing right now, okay? So parallel to, when you have parallel lines, that means your slopes are equal, identically equal, okay? So the slope of f is positive 2, so that means the slope of g, we'll just call it g, also has to be a positive 2, okay? And then we have some some y-intercept, which we don't know. But we also are given that it has to pass through this point 2, 7. So we can plug that in, that x and y value, and figure out our b. So we have 7 is equal to 2 times 2 plus b. I don't know, I'm trying to write a 3 there. Anyway, so this is 7 equals 4 plus b. I was trying to give it away. So then b is equal to 3. There we are. Okay, so we have, this is 3. So g of x, our other line that we weren't given, is 2x plus 3. Okay, so let's graph these and see what our parallelogram looks like. Okay, so let's say we have y, and here's x, and y. Okay, let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, just in case. So we have 2, 4, 6, 8. Alright, and then we have 1, 2, 3, 4. 1, 2, 3. Okay, so here's 2, 4. There's negative 2. Let's graph some things. So the y-axis, I'm just going to make that a little bit darker. Okay, so this is one of the bounds here. Okay, another one is the vertical line where x is equal to 3. Okay, so that one looks like this. We're just going to draw a straight up and down line. Okay, so these are two bounds, so it has to stay in between here. The line 1 plus 2x, so 1 plus 2x, that has a y-intercept of 1, and it has a slope of 2. So up 2 over 1, up 2 over 1, up 2, and over 1. Okay, so something like that. And so we have the point, this is the point 0, 1. And don't worry, I'll draw this parallelogram bigger and label the points and everything. So we have something that looks like this. And then we also have another line, this g of x, that guy, where it has a y-intercept of 3, okay? And then still the same slope of 2. 2 over 1. So 2 over 1, like that, something like this, and then up 2 over 1, up there. Okay, so we have this parallelogram formed by those 4 lines, okay? So this guy right in here that I'm shading in. So what we're supposed to do is find the area of that, okay? So let's continue this on the next slide. So let me draw our parallelogram again. So it's something like this, which those lines are not parallel, so it didn't look like that. Okay, let me work on that here. Okay, so we had a parallelogram that looks something like this. Okay, and I'm just going to label the points at this point. Okay, so this is 0, 3. This is 0, 1. Okay, let me draw little points here. Okay. This one up here at the top right is 3, 9, and this guy here is 3, 7. Okay, so we have something like this, and we're supposed to find the area of this. So here we do have to get a little bit creative with geometry and whatnot. So what I'm going to do is kind of extend these vertical lines up on this side and down on this side. And then I'm going to draw like some horizontal lines just to make a box looking thing, because it's really easy to find the area of a rectangle, right? And we can just subtract away the area of these kind of imaginary triangles that we're creating in order to get the area of this one parallelogram, okay? So what is the width of our rectangle? We just have to subtract the x value. So this would be, the x value over here is 3, the x value over here is 0, so the width is going to be 3, okay? How about the height of our rectangle here? So that would be the height up here, this is y equals 9, and the one down here is y equals 1. Alright, it's not 0, but a 1. Alrighty? So 9 minus 1 is going to be 8, so the height here is 8. So the area of our rectangle is going to be 3 times 8, which equals 24. And that by itself is not the area of our parallelogram. That's way more than we need, right? We have to subtract out these imaginary triangles, okay? So let's find the area of one of them, which is actually symmetric. So we're just going to subtract away the 2 times the area of one of the triangles that we find, okay? So let's find the area of a triangle. So we already have that the base here is 3. Now we just need to know the height here. So that would be given by 7 minus a 1, right? Because we're subtracting the y heights. So from here to here, 7 minus 1 is equal to 6. So this is equal to 1/2 base times height, 3 times 6. So this cancels and becomes a 3. That's a really weird 3. So area of one triangle is 9. So we're just going to plug that in here and get that. Well, the area of our parallelogram, which I'll draw like a slanted rectangle, is equal to area of our rectangle, okay? And then minus 2 times the area of our triangle, okay? So this is equal to 24 was the area of our rectangle, right? Kind of ignore this part over here now. So the area of our rectangle was 24 minus 2 times the area of our triangle, so that would be 9. So that's 24 minus 18, which is equal to 6. Okay, so our answer is going to be, and we weren't given units, so we could just say, in general, 6 square units is the area of our parallelogram formed by those 4 lines. Alright, that wraps up the practice problems video for the section on modeling with linear functions. I hope that helps, and good luck on your homework.